Hello everyone, this is Eric. Welcome to my YouTube channel. So today we going to summarize on the book, Where Good Ideas Come From, by Steven Johnson. So let's get start. Lesson 1, Evolution and innovation usually happen in the realm of the adjacent possible. 4 billion years ago, carbon atoms mulled around the primordial soup. But as life began, those atoms did not spontaneously arrange themselves into complex life forms like sunflowers or squirrels. First, they had to form simpler structures like molecules, polymers, proteins, cells, primitive organisms, and so forth. Each step along the way opened up possibilities for new combinations, expanding the realm of what was possible, until finally a carbon atom could reside in a sunflower. Similarly, eBay could not be created in the 1950s. First, someone had to invent computers, then a way to connect those computers, then a World Wide Web for people to browse, and then a platform which supported online payments. Both evolution and innovation tend to happen within the bounds of the adjacent possible, in other words, the realm of possibilities available at any given moment. Great leaps beyond the adjacent possible are rare and doomed to be short-term failures. The environment is simply not ready for them yet. Had YouTube been launched in the 1990s, it would have flopped, since neither the fast internet connections nor the software required to view videos was available then. The predominance of multiples in innovation highlights how the adjacent possible is constrained by existing parts and knowledge. A multiple occurs when several people independently make the same discovery almost simultaneously. Joseph Priestley and Carl Wilhelm Scheele isolated oxygen in 1772 to 1774, unaware of the other's advancement. But they did share the same starting point, because their search for oxygen could not begin until the gaseous nature of air was first understood. Thus it was inevitable some scientists would reach their discoveries at around the same time. Lesson 2, world-changing ideas generally evolve over time as slow hunches rather than sudden breakthroughs. Although in retrospect great discoveries may seem like single, definable eureka moments, in reality they tend to fade into view slowly. They are like gradually maturing slow hunches, which demand time and cultivation to bloom. According to Darwin, the theory of natural selection simply popped into his head when he was contemplating Malthus' writings on population growth. But Darwin's notebooks reveal that far before this so-called epiphany, he had already described a very nearly complete theory of natural selection. This slow hunch only matured into a fully formed theory over time. Only in retrospect does the idea seem so obvious that it must have come in a flash of insight. Upon hearing of the theory for the first time, a supporter of Darwin even exclaimed, "How incredibly stupid not to think of that." Another slow hunch led to a revolution in the way we share information today. As a child, Tim Berners-Lee read a Victorian-era how-to book and was fascinated by the portal of information he had found. Well over a decade later, working as a consultant at the Swiss CERN laboratory and partially inspired by the book, he tinkered with a side project which allowed him to store and connect chunks of information, like nodes in a network. Another decade later, CERN officially authorized him to work on the project, which finally matured into a network where documents on different computers could be connected through hypertext links. After decades of Berners-Lee's slow hunch maturing and developing, the World Wide Web was born. Lesson 3, platforms are like springboards for innovations. Ecologists use the term keystone species to describe organisms which are disproportionately important to the welfare of the ecosystem. On a small island with no other predators, a pack of wolves keeps the population of sheep under control, thus stopping them from eating the island bare and collapsing the entire ecosystem. But around 2 decades ago, ecologists understood that a very specific and important type of keystone species warranted its own term entirely. Ecosystem engineers actually create habitats for other organisms, building platforms from which several others benefit. Consider for example the beavers that dam rivers turning forests into wetlands, or the coral that builds thriving reefs into the middle of the ocean. Such platforms exist in the sphere if innovation is well, and they are used as springboards to leap into the adjacent possible. The Global Positioning System, GPS, is a good example of such a platform. Originally developed for military use, it has now spurned countless innovations from GPS trackers to location-based services and advertising. Platforms often stack on top of each other, meaning that one platform provides the foundation for even more platforms, which again produce countless new innovations. Beavers fell trees that rot and attract woodpeckers to drill nesting holes in them. But once the woodpeckers have left, these holes are occupied by songbirds. The woodpecker has also created a platform. The story of Twitter is similar. The web was based on existing protocols, Twitter was built on the web, and now countless apps have been designed on the Twitter platform, the adjacent possible being expanded at every step. Ideas rise in crowds, as Poincaré said. They rise in liquid networks, where connection is valued more than protection. Lesson 4. Innovation and evolution thrive in large networks. The basis of all life on Earth, and likely any extraterrestrial life out there, is carbon, because it is fundamentally good at connecting with other atoms, and can thus construct complex chains of molecules. These connections allow new structures like proteins to emerge. Without carbon, the Earth would have likely remained a dead soup of chemicals. Connections also facilitate ideas. When humans first began to organize themselves into settlements, towns and cities, they became members of networks, which exposed them to new ideas and allowed them to spread their own discoveries. Before this happened, a novel idea by one person could well die with her, since she had no network to spread it to. Great ideas rise in crowds. To better understand the roots of scientific breakthroughs, in the 1990s psychologists decided to record everything that went on in 4 molecular biology laboratories. One imagines that in a field like molecular biology, great discoveries are made by peering through a microscope. Strikingly, it turned out the most important ideas arose during regular lab meetings, where the scientists informally discussed their work. Other studies have shown that the most creative individuals have broad social networks that extend outside their own organization, and hence get new ideas from many different contexts. Cities facilitate such large networks which allow ideas to be diffused and combined in novel ways. This is one of the reasons why cities are disproportionately more creative than smaller towns. Today, though, the greatest such creative network is not a city at all, but the World Wide Web, creating, connecting and diffusing ideas more effectively than any network before it. For part -2. Please like and subscribe to our channel and hit bell icon.